So this is question 3 of the Sample Assessment Materials Paper 2 for Edexcel Physics, GCSE 9-1, and it's the higher tier version. So question 3, a student investigates how the resistance of a thermistor varies with temperature. The student sets up the circuit shown in figure 5 to measure current and voltage. He finds that it does not work. Give 3 modifications the student should make to the circuit so that the circuit works correctly. The first thing that's wrong is these batteries or these cells, they are opposing each other. This means they'll cancel each other out, so they just won't work. So the first thing you need to do is turn one cell the other way around. Doesn't matter which, as long as he does it to one and not both. If he does it to both, it'll cancel out again. 2 and 3, you can write in one go, which confused me a little bit because I was trying to find a third thing. The voltmeter and the ammeter are the wrong way around. So I'm going to write switch, voltmeter, and ammeter. Because a voltmeter always needs to be in parallel with a component, and an ammeter always needs to be in series with a component. And that gets you both marks. You can get both marks just saying switch the voltmeter and the ammeter. Then we've got part B, so I'll keep this just next to me for reference. The student uses the equipment shown in figure 6 to measure the temperature of the thermistor. We've got a thermometer, we've got the thermistor with some wires to the circuit, we've got a stirrer, all in a water bath with a heater. And it says give one reason for using the water bath. You might have done some experiments in chemistry where you use a water bath, probably less likely in physics, although they would be quite useful for this. Water baths mean that you have a more constant temperature throughout the water, and the water is heated gradually, which means it's more likely to be the same temperature everywhere. And that means that if the water's heating gradually and is the same temperature everywhere, it's likely that the thermistor is the same temperature. If you do it in a beaker with a Bunsen burner, the thermistor might not be the same temperature as the water that you're measuring. So I'm going to write constant temperature throughout the water. So water and thermistor at same temperature. Because we can't measure the temperature of the thermistor and we can't put the thermometer on it, it doesn't really work that way. We have to just measure the temperature of the water and hope that that isn't the same as the thermistor. And one way to make it more likely to be the same is to use a water bath where it's heated slowly and all the water is the same temperature. Okay, part 2, the equipment shown in figure 6 is for investigations in the temperature range from 20 to 100 degrees C. State one way the student could develop this experimental procedure to investigate temperatures outside this range. So either below 20 degrees or above 100 degrees. Now, to get below 20 degrees is quite easy, so I'm going to go for that one. I'm going to say add ice to cool water below 20 degrees C. There would be a minimum there of 0 degrees C, because if you keep adding ice, it's not going to then freeze, or you'd have to add an awful lot to make it then freeze. You couldn't just increase the temperature of the water, because once the water hits 100 degrees Celsius, it will boil, but you could choose a different liquid that had a higher boiling point. That would work as another version of getting the mark. And then part C, the student takes measurements for 2 of the components A and B. The results for both these components are shown in figure 7. And the question is going to ask us to compare these. So compare and contrast how the resistance of component A and component B vary with temperature. So we'll have a look. So as temperature increases, the resistance for A decreases. For B, as temperature increases, the resistance increases. Now it says compare and contrast. It wants similarities as well as differences. The difference is that one goes up and the other one goes down. Similarities, they both change. Some components don't have a changing resistance with temperature. A fixed resistor should stay at the same resistance no matter what the temperature, to an extent. Another variation on that, what's the same between them? Well, although they both increase or decrease, they both do so non-linearly. We can't see any straight lines here. This could be a 1/over relationship, but I can't say that for sure. And this definitely isn't a linear relationship. So I'm going to write that as my thing. So I'm going to say for A, as the temperature increases, and do write the actual word temperature in the exam, resistance decreases. For B, as temperature increases, resistance increases. And then I'm going to say for both, resistance change with the temperature non-linearly. And that's definitely covered all the boxes. Examples of what these could be. This could be a filament lamp. Probably not, but it could be. Or it could be a normal resistor that's past its limit. And this will probably be a thermistor. For a decreasing resistance with increasing temperature, it's probably going to be a thermistor there. And finally, component A is connected to a 12 volt supply. Which of these is the current in component A when the temperature is 80 degrees C? So what can we find out there? So component A at 80 degrees C has a resistance as 5,000 ohms. So I know a resistance and I know a voltage and I want to know a current. So I'm going to use the equation V equals IR, but rearranged I equals V over R equals the voltage, which is 12, divided by the resistance at 80, which is 5,000, which gives us the answer